Riskomon is an interactive visualization tool for the exploration of a Riskomon set of scoring system models. That is, a collection of equally good risk score models obtained from the faster risk algorithm. Each column here represents a different risk score model. All the models here have loss close to the best loss possible on the given training set. The yellow stripe indicates a selected model which, when selected, then shows up at the bottom of the screen. The Riskomon graphical user interface has 4 components: the control strip, the features pane, the models pane, and the cards pane. The control strip shows the number of models and the number of features present in the Riskomon set dataset loaded. The first drop-down menu allows the user to pick between different pre-computed Riskomon set datasets. The default one is about risk of breast cancer. The second drop-down menu changes the view atop of the models pane. By default, we're looking at the logistic loss of these models. Other views include the training accuracy, area under the curve, and full risk profile, which is more than one data point per model. The third button of the control strip toggles between the default color map and the alternative monochrome view. The color map view maps red to positive coefficients, meaning that those coefficients add risk to the particular model. In contrast, negative coefficients with blue subtract risk from the particular model. The features pane on the left shows all the features that appear across the Riskomon set. For each row, the blue number on the left reports the number of models containing that feature. By default, feature rows are ordered by popularity, with features that have more models above. Using the handle to the right of the feature name, users can drag and drop features to reorder the rows. The models pane shows each model as a column. Connected by a vertical line, each bubble in the column represents a feature that appears in the model, and the number within the bubble represents the coefficient of that feature. The order of the model columns depends on the order of the rows. Moving the feature rows on the left will change the order in which the model columns appear. The leftmost columns show the models containing the greatest number of features at the top rows of the list on the left. The cards pane at the bottom reveals the card view of the selected model columns. By default, the first model is selected. Selecting more models reveals the card views, which can overflow, so horizontal panning is enabled. By clicking on the X's for each card, they can be closed, and also by deselecting on the model's view. Each model's card view lists all the features that constitute that model, along with their respective score coefficients. The sigmoid risk curve shows how the scores, which are the sum of the coefficients, are translated into risk percentages encoded as blue circles along the vertical axis. The larger the dot, the higher the risk. The range of the scores reflects all possible coefficient combinations. At the bottom of the card, we report the actual numbers of the 4 model statistics. Now we briefly walk through a use case scenario in which a medical expert decides which model to use for analyzing breast cancer lesions in a mammogram. Expert opinion says that age greater or equal than 30 is not a good feature to have because most women under 30 do not get mammograms. So we demote this feature to the bottom row. Expert opinion says that a spiculated margin is an important feature to have, so we promote it to the top row. Likewise, oval shape is another feature we're interested in. Arrows pointing up that are green signal that the features have been promoted, while arrows pointing down that are purple notify that the feature has been demoted. Notice that the feature that was selected by default is now in a different location. This is because our arrangement of the feature rows. Satisfied with the feature reorder based on expert opinion, now the model columns have reordered and settled into a configuration we can explore. We can see that models 3, 22, and 20 have both features that we promoted. However, model 22 and 20 also have the features that we demoted, so we unselect them. This leaves only model 3 as the model that satisfies all the constraints that we set. However, our second most interesting feature, has models between 6 and 12 that also do not feature the demoted feature. We can explore this neighborhood and maybe find models that we have not considered yet that may be of interest. To further support exploration, Riskomon maximizes visual real estate to accommodate as much of the Rashomon set in the screen at once, a key affordance to support datasets of any size.